Ellipse. The next conic which we're going to discuss here is ellipse. As we have seen that ellipse is the conic section of a cone when cut other than 90 degrees. As we have seen in the previous case that a cone which has the height and the radius is cut slantingly or sliced slantingly, we get an ellipse. That's how this is cut, and we get this conic section, which is an ellipse. So when this is cut other than 90 degrees to the height of the cone, we get slantingly the area of cross section, which is an ellipse. So the cross section gives us a conic section ellipse. So we're going to study in this topic about the various topics of ellipse or the properties. Now that we have discussed about the ellipse related to eccentricity, let's recap with the ellipse. The ellipse, which generally looks in the shape of egg-shaped structure, with this being x-axis and this being y-axis, we have the focus and the point P, which is given by SP. Now I have a directrix which is a fixed line for the fixed point S. This. Now we have the definition of ellipse, which is generated from the fixed point S and a fixed line L, which is called the directrix, and this which is called the focus. The fixed point S and the fixed line L generate the ellipse, provided that SP by PM, which is denoted with eccentricity E, is less than 1. That's how we define the ellipse. If SP by PM is less than 1, we call this as an ellipse, where S is the fixed point and this is the fixed line, the directrix L. So SP by PM is less than 1, or SP less than PM equal to E is how we define the ellipse. Now let's see equation of ellipse in standard form. So as we have equation of ellipse in standard form, which we're going to discuss here. Now we know that an ellipse is generally an oval shaped structure in this form, which is exactly symmetric about x-axis and y-axis. This is exactly in the center, where this is origin and this is the focus and this is the point on the ellipse, and this is the directrix L, and this is joined by SP and PM, and this is the point of intersection of the axis and the directrix. So Z is foot of perpendicular from focus to the directrix, and this is the vertex of the parabola of the ellipse, or this is where the center of ellipse, and I have A dash, and this is B dash. Now corresponding to this focus, I have a focus on the left which is S dash, which is image or reflection of S with respect to y axis. Now this is the directrix L dash with respect to point P dash connected with PM dash, and this with Z dash is how we define the ellipse with all its properties. This is how we get the whole of ellipse with each of them defined in this way. So here S and S dash are called foci of the ellipse. The plural of focus is foci, and then are called directrix, and then I have S dash and L dash and C, which is center of ellipse, is how I understand each of the structures or the properties of the ellipse in standard form. Now, what is the equation of ellipse in standard form is what we're going to discuss in the session continued. Now let's see what are the coordinates of each of C, S, S dash, Z, Z dash, A dash, B dash, etc. So we'll see each of the coordinates and then define the equation of standard form of ellipse. So we know that the center is in the origin, so the coordinates of C are 0, 0, and the focus on the right is given by the coordinates AE, 0, and the coordinates of S dash are minus AE, 0, because it is exactly on the left and this distance equals this. On the negative side, this will be minus AE, 0, and the coordinates of A are A0, and the coordinates of A dash are minus A0, and the coordinates of B are 0B, and the coordinates of B dash is 0 minus B because it's on the down. So this makes me understand that CA is A and CA dash is also A, that is negative side of A, and CB is B and CB dash also is B, as I can see. So this is A and this is A, so AA dash will be 2A. And BB dash will be 2B, as we can see here. Now clearly I see that this is greater than this because this is flattened and this is bulged. So AA dash, in this case, the condition is that AA dash is greater than BB dash. That implies 2A is greater than 2B. That implies A must be greater than B. So for this kind of an ellipse, A must be greater than B is how we understand. So A is greater than B, as can be clearly seen in the diagram where this is larger than this distance out here. So A greater than B for this ellipse. The focus, the center and A is given, and the coordinates of the foot of perpendicular from focus to the directrix, which is Z. Z is the foot of perpendicular from focus to the directrix, and Z dash is the foot of perpendicular from focus S dash to the directrix L dash is what we see here. So the coordinates of Z are given to be a by e comma 0, and the coordinates of Z dash are given to be minus a by e comma 0. And we know that equation of this axis is y equal to 0, and the equation of this axis is x equal to 0. Now this is called major axis because it has the major segment of the ellipse, and this is called the minor axis because this has the minor segment of the ellipse. So this is the major axis, and this is the minor axis because this has the major segment along x-axis and minor segment along y-axis. Now with this, we are going to define the whole of the equation of ellipse in standard form. Now also, as I see that the coordinates of z is a by e comma 0 and this line is parallel to y-axis, therefore equation of directrix is given to be, as can be seen here, the coordinates of z are a by e comma 0, then the equation of directrix is given by the line which is parallel to y-axis. Therefore, this line being parallel to y-axis has its equation in the form with x equal to 0. This will be x equals a by e. And here the equation of L dash with x coordinate being minus a by e will have x equals minus a by e are the two equations of directrices as we have here with L and L dash. Now with the condition that a is greater than b and both a and b are greater than 0, and for eccentricity e which lies between 0 and 1 because e is less than 1 for ellipse and e is obviously greater than 0. So e lies between 0 and 1. So therefore, with the condition that a is greater than b and this is this and this is this, the equation of ellipse in standard form is given by with b square equals is what we get as the condition. The condition b square equals a square into 1 minus e square is the condition for standard form of ellipse. Now let's see the case where a is less than b. In the previous case, a is greater than b, so the ellipse was having its major axis along x-axis. So for a less than b, for ab greater than 0 and 0 less than e less than 1, let's take the case 1 of a less than b. So for the case of a less than b, I have the ellipse which is in the shape inverted out here. In the previous case, it was in this shape and now it turns onto y-axis. The major axis turns onto y-axis and the minor axis turns onto x-axis. Is how we see the difference between a greater than b and a less than b. Now the center of ellipse is this, which is 0 comma 0, and this is a dash and b dash. My focus shifts here and my s dash also is here, and then we have the directrix. So in this case of x-axis and y-axis along which I have the ellipse with a less than b, then my focus here is 0 comma BE and 0 comma minus BE is what we get as the focus, and A is A comma 0 minus A0 and B is 0B and 0 minus B, and coordinates of Z is 0 comma B by E and Z dash is 0 minus B by E, and equation of directrix is y equals B by E and y equals minus B by E. Equation of minor axis is y equal to 0 and equation of major axis is x equals 0 is how we get each of the properties which we have identified in the previous case. The only difference being that the major axis shifts to y-axis and minor axis shifts to x-axis as in the previous case. And equation of ellipse is given by x square by a square plus y square by b square equal to 1. A square equals b square of 1 minus a square. Now we clearly see that the whole of ellipse in the previous case is shifted to this, then for a greater than b shifted to a less than b, all b squares are replaced with minus b square, and therefore I get the condition a square equals b square times 1 minus e square for this ellipse. And we have the length of major axis or the length of minor axis in case of this being AA dash and BB dash, which is 2B, and AA dash, which is 2A. The equation of ellipse in standard form is given as x squared by a square plus y squared by b square equal to 1 for a greater than b. And for this, we know that the eccentricity lies between 0 and 1 for the ellipse. Let's see what is the value of eccentricity. Now for this ellipse, we know that b square is a square times 1 minus e square, and for this we have b square is a square minus a square e square when expanded to the brackets. Now we want to make e the subject, so I take all e terms to the left, and therefore I get a square e square is a square minus b square. That implies e square is a square minus b square by a square. This on simplification gives but I do not take the plus minus value because since e lies between 0 and 1, therefore e is plus of root of a square minus b square by a square is what we get as eccentricity of the ellipse, or this can also be taken as root of a square minus b square by a is what we get as eccentricity of the ellipse. Now for the equation of ellipse in standard form, where I have case 2 with a less than b, then let's see how we get the eccentricity formula. So in case of a less than b, we have a square equals b square times 1 minus e square as the formula. That implies this on simplification gives a square as b square minus b square e square. which on simplification gives b square a square is b square minus a square. This as this, but I take only the minus value since 0 less than e less than 1. Therefore, e is root of b square minus a square by b square, or e is root of b square minus a square by b. This is how I get the eccentricity formula connected with the equation of ellipse, with a less than b as case 2 of the formula.